So our last couple examples that we're going to look at with respect to spheres is those with spheres of inequalities. So we're just going to draw the solids satisfying each of the conditions. So we have a really easy sphere, x squared, y squared, z squared is less than 36. All right, so first of all, the center of the sphere is at the origin. And I think it's pretty clear because we don't have x minus a number, y minus a number, z minus a number squared, etc. The radius of this sphere is the square root of 36, clearly 6. And because it is a less than, it is everything that is not on the sphere, and since it's less than, it's everything inside but not on. In but not on the sphere. All right, so if I was to draw this as best as I can, we're going to have a sphere. So we're going to have the radius is equal to 6. Now I am going to cheat a little bit because it's not supposed to be anything on the sphere. So what I'm going to do is I'm going to have to draw this as a hyphenated sphere. So I'm going to do this as best as I can. Right. So here's our hyphenated sphere. And it's going to be everything that's all the volume that's inside of that sphere, but not on it. So everything inside, but not on it. Generally, when I give you guys the exam questions, what I'll say is I'll either say describe or draw it. Okay, so for this one, what you would say if I asked you to draw it, you would say that the center is at 0, 0, 0, the radius is equal to 6, and you would tell me that it's all volume inside but not on the sphere. All right, so be very specific if you do decide to describe it as opposed to drawing it. A second example, x squared plus y squared plus z squared greater than or equal to 4x minus 6y plus 8z minus 13. Now, the good news is that we know it's a sphere because when we look at it, we know that the coefficients of x, y, and z are the same. However, it's not immediate as to what the center is because we're going to have to complete the square. So let's rewrite this. I'm going to take the 4x and I'm going to take the 6y and the 8z and I'm going to move all those over to the left side and group it. So I'm going to get x squared minus 4x, I'm going to leave a space, plus y squared plus 6y, leaving a space, z squared minus 8z, leave a space, and that's going to be greater than or equal to negative 13. We're going to take half of each of the middle coefficients, and we're going to square those and add it to each side. Half of negative 4 is negative 2, negative 2 squared is 4. Half of 6, 3, 3 squared is 9. Half of negative 8 is negative 4, negative 4 squared is 16. And I'm going to add those values, 4, 9, and 16, to both sides of our equation. Okay, or our inequality in this case, excuse me. Now we're going to factor. Remember, take the square root of the first term, square root of the last term, and then you put the sign that's in the middle there. And when we combine these, we should wind up with greater than or equal to 16, since the 4, 9, and negative 13 are going to cancel out. All right. Now be careful because it's not just the sphere, but it's all the volume. Okay. So I'm going to draw it first. So we have our center is at negative 2. I'm sorry, positive 2, negative 3, 4, and the radius is the square root of 16, which is 4. If I were to draw this as best as I can, and I'm going to need the y negative to be able to do this correctly. So we have 2, we have 4, or negative 3, excuse me, so this is y minus x plus, and we have z plus. Okay, so if we were to line this up as best as we can, here's the center of our sphere. It does have a radius of 4, all right? And let me erase this just because we already know what the center is. We plotted it. And then the radius of 4 means that it should end up just touching this y-negative axis when we construct the circle, or at least that part of the sphere. So if you can imagine something like this, it should probably cross a little bit into the other territory, or the other octant, if you would. So just imagine it as best as you can. It's a little bit difficult to draw on the monitor, as you can imagine. And the last thing we need to do is we need to describe what the volume is. Now, since it's a greater than, it's going to be outside or on. All right, so we just have to be careful when we do this. So we're going to graph. And because we already we constructed it as a solid sphere, then that already describes it. All right. However, if we were to describe this, okay, what we would say is that it is all volume on or outside the sphere. Radius is equal to 4. Center is at 2, -3, 4. All right, so whichever you prefer, describe it or draw it, doesn't really matter to me. However, you have to make sure you can do one of those two. All right. So in the next video series, we're going to go through and start talking about vectors in 3 dimensions.